Good afternoon, and we'll get started with the webinar in just a few moments. Okay, we'll go ahead and begin. Hi, good afternoon. My name is Joe Milazzo. I'm with the Regional Transportation Alliance, voice of the regional business community on transportation. I want to welcome you to today's Innovation and Solution Series webinar. And we'll go back to the previous slide for just 1 second. Yep, today's webinar is presented by the Regional Transportation Alliance Business Coalition in partnership with the Research Triangle Cleantech Cluster and NCDOT. This is the second of 2 days for the webinar. The prior day's information is available on the website that you see on your screen. I want to point you to the social media on the lower left of your screen, tagging at RTA Triangle and then also RTA INNOV series for the hashtag that we'll be using today. If you were here yesterday, we're using the exact same for both days. So thank you for those who are already part of that. We greatly appreciate that. And we'll go to the next slide. As I mentioned, we're the voice of the business community on transportation in the Research Triangle market. Our job is to provide regional business leadership to get our region moving faster. And that's hopefully what we'll be able to do again today, just as yesterday, and we will be done today by 3:30. And we'll go to the next slide. RTA has a number of members, a number of major investors. We'll begin with our gold members. We won't read them all, but we'll pause for a few moments just so you can see the names of those companies that are investing, not just in this organization, but in this community. We'll go to the next one. And here you can see also the other members of the RTA leadership team. These are our RTA Silver members. We continue to grow there as well, and we'll pause for just a few moments so you can see these investors, and we thank each of these members and our gold members for their commitment to the Research Triangle region and business leadership. And we'll go to the next one. Of course, RTA is a business leadership group, works in concert with a number of partners. You can see some of our senior regional partners at the top of your screen, and also our bronze members who also contribute tremendously to the success of the organization and this market. And we'll pause for a moment. We'll continue. So at this time, we're going to transition over to some of our partners. Again, as I mentioned previously, this event is being in partnership with 2 organizations, and one of which is the Research Triangle Cleantech Cluster. So my colleague Emmett Owens will offer some perspectives as well. Emmett.
Well, thank you, Joe, and thank you, Natalie, for the opportunity to partner on this event. First, I hope everyone participating in today's meeting is doing well given the circumstances. I'm here just to provide a brief 2-minute overview of the Research Triangle Cleantech Cluster and to give some context of who we are and what we do. So RTCC is a membership-led organization. We work together with industry, academia, and government to strengthen cleantech in the Triangle and broadly in North Carolina. As you can see on this slide, our 4 main focus areas are broadly centered around economic development. Next slide, please. We wouldn't be here without any of our members whom like Cisco, ABB, and RTI International, and many others who are innovating in the transportation space. So we're really appreciative of our members, and I encourage you to check out our website at researchtrianglecleantech.org to learn more about some of the work we're doing. I also want to take this opportunity to highlight some of the work we're doing with our partner in Charlotte, the Jules Accelerator, to create a cleantech corridor between Raleigh and Charlotte. Really, it's a statewide focused effort. You can check out the ncleantechcorridor.org to learn more. Love to figure out a way to plug in if you're interested. And then also, we have a few upcoming events taking place over the next few months. Keep your eye out for some additional webinars we're going to host in the next few months. And thank you again to Natalie and Joe and all the speakers for today's event. And I'll turn it over to Mr. Hummer now. Thank you very much. Hope you have a great day.
Thank you, Emmett. And on behalf of NCDOT, I want to welcome you to this webinar and thank you for being here with us today, spending part of your day learning about some new transportation technology that could help advance all of us in moving more efficiently and more safely around our region. NCDOT has been a partner with RTA for many years now, and we sure appreciate that partnership. For instance, on I-40 and helping that key corridor through our area, and then more recently with the, for instance, dynamic left turn intersection that you heard about yesterday, and the FAST study that's just kicking off. So those are just a couple of examples of ways that RTA and NCDOT are teaming up to help keep things moving in the triangle, and we really appreciate that. So without further ado, back to Joe Milazzo. Thank you very much for being here, and thank you, Joe, for putting this on and continuing the good work.
You're welcome. Dr. Hummer, we appreciate the partnership with the department. We appreciate the longstanding partnership with NCDOT, also our partners again with the Clean Tech Cluster, and also each of you today for being a part of today's event. Again, you can see the hashtag, you can see the social media information, and again, where the webinars will be posted by the end of the week. At this time, it gives me an honor to welcome our two presenters for today's event, and we have two of them. First is Dr. Stuart Ginn. He is the medical director for WakeMed Innovations, and he is going to do a revision and extension of his remarks from our annual meeting. He did a fantastic job. The only challenge we had was just there simply wasn't enough time to do it justice. We asked if he would be willing to give some additional commentary and additional background. He graciously agreed to do so, and so we're excited to have him. So he's going to be speaking in just a moment. And then after him, we're going to have Joshua Dodson. He's an IoT sales specialist with Cisco Systems, and he's going to be offering some different perspectives on elements of technology that Dr. Hummer mentioned and how that's going to be impacting transportation, not just now, but as we go forward. So I'm going to turn the presentation over to my colleague, Natalie Ridout, who is going to help coordinate all of the presenters and the presentations, and we will welcome her. So Natalie, take it away.
Good afternoon. Thank you everyone for joining us. I'm very pleased to kick us off with Dr. Stuart Ginn. Stuart, we are now activating your panelist role, and you should be able to share your screen. One moment. And we are ready when you are.
Okay.
Great.
Well, thank you, Natalie and Joe. I really appreciate the opportunity to be here today. As Joe mentioned, it was nobody's fault but my own, but I was given 5 minutes at the lunch session, and I don't think I've ever been able to do a presentation in 5 minutes ever, and I proved that to be correct. So I appreciate their flexibility, and I was thrilled to hear that there was interest in hearing more about what we've been doing at WakeMed with our drone program and other emerging mobility technologies. So I'll just jump right in. As Joe said, I'm Stuart Ginn. I am an ENT head and neck surgeon at WakeMed. That's my day job. I also am the medical director of WakeMed Innovations at WakeMed. I'm a former pilot and flight instructor, which will make a little bit of more sense why I'm telling you that in a few minutes. And what I'm going to do today is talk to you a little bit about drones as a technology in healthcare, but also beyond healthcare. We're going to do an overview of the history of the program that WakeMed has been involved with over the last couple of years to give you some background, its successes, its challenges. I think it's illustrative of the state of the industry in terms of drone technology in those regards. Then we're going to take a bit of a broader view once we've covered that ground and talk a little bit about drones and the evolving mobility ecosystem that they're a part of, why they defy categorization as a transport or possibly even an infrastructure technology and the implications of that. And then a little bit about why they might be disruptive, and we'll talk about the definition of that term in a little bit more detail. And then briefly, I'm going to bring those concepts back around to healthcare and talk about why it's relevant and why redefining healthcare systems is enabled by these emerging transportation technologies, including drones. Okay. So just to speak a little bit about the background of WakeMed's drone program, this all started with a need. The need, everything we do in innovations, we think first about the problems we're encountering and the problems we'd like to solve for our patients and for our healthcare system delivering care to those patients. The need that we had identified for many years had been issues with our courier systems, and not because of any individual vendor issues, but mostly because as our system continued to grow, we put more and more pressure on those systems to deliver small parcels around our growing footprint of facilities. And we didn't have very good visibility. We certainly didn't like the cost associated with it. And frankly, because it was often outsourced and doubly outsourced to second and third parties, we didn't find it to be a very reliable system. Because of my background in aviation, we basically started fooling around with the idea of using drones on a theoretical basis to solve that problem, but more as a way to examine how drone technology could be integrated into a healthcare system. I knew very well at the time that there was no legal pathway, regulatory pathway in place to make that possible, but we also had been watching drone technologies mature to the point where they were becoming viable technologies to use on an industrial scale, to put it one way. We therefore developed an internal model for a theoretical drone network connecting our 3 hospitals and our what we call health plexes, which are freestanding emergency departments with other services. We matched those specifications with this new emerging technology and looked at providers of drones and decided on a good match. We selected a company called Matternet, who is still our provider, and you'll see pictures of their technology soon. There's Matternet. They're based in California, have been active in Switzerland and actually globally, and now increasingly in the United States, beginning with our program. And then we had essentially set up a model and a partnership, but had nowhere to go. We didn't have a regulatory pathway in place to allow us to do this. We were planning on approaching the FAA, the Federal Aviation Administration, about it on an ad hoc basis, which was the model at the time. But in the interval, the integration pilot program was announced, which is a federally sponsored but state level organized and driven program to basically extend advanced uses of drones and similar technologies so that the FAA, NASA, and other stakeholders could work on developing the regulatory frameworks that will guide use of these technologies as they scale. So we were lucky to apply through a partnership we developed with the North Carolina DOT. The DOT is the lead and central partner in that application and that organization, and then we did that with our partners. Initially, Matternet, WakeMed, several other technology partners, and eventually UPS then joined. Once we started running the operation, we did a demo in August a year and a half ago. As we did that demo, UPS became interested, approached us, and then we started working with UPS on a more permanent basis. Once UPS joined, things changed a little bit for the better, and we were able to get much more traction in developing the regulatory framework through the FAA. That has led to a larger partnership around healthcare logistics and between UPS and WakeMed that I'll talk a little bit more about later. So the progress is that we started this through the IPP. We were selected, we think, because the healthcare use case is strategic. It has the potential for public benefit in addition to economic development benefit. And put another way, the bar is a little bit lower. I don't want that to sound the wrong way, but when we're talking about piloting new technologies out there in the public domain, you need a good reason to do it, and healthcare is a really good reason. We were able to establish the country's first drone-based medical package delivery system in actually March of last year. Since March of last year, we've been operating on our first route, which is the pilot route, a very short route, about 1/3 of a mile across a relatively busy street from an outpatient facility next to WakeMed Hospital over to the main campus where the main lab is housed, and currently we use it to transport blood samples and for routine clinic visits and things like that. We've been doing this daily now, 9 or 10 times a day for a year with interval periods of shutting down the system to update it, and the usual stuff. But this has been an evolving partnership with UPS. We found it to be a very novel approach to healthcare system redesign, which I'll speak to in a little bit. And it's really opened our eyes at WakeMed and among our partners to ways that mobility and automation technologies can impact healthcare. In the future, we anticipate scaling this system. As I said, the initial application included a full-scale network involving all of our facilities. In principle, that will happen. Of course, everything we do and every step we take is in lockstep with the FAA and other stakeholders. And so when we start talking about flying well beyond line of sight, we obviously go very slow and carefully. But from a healthcare standpoint, we're ready to use this technology on that scale. And the limitation at this point is essentially regulatory, and all of our partners, including the FAA, making sure that everything is being done appropriately and safely, which we obviously support. We really think differently about this technology now. We used to think about it as a quick, reliable way to move things around our healthcare system. But what we've realized is that as we scale it up, the real opportunity is in thinking through how that can help us reshape our healthcare system. How can we expand services at new locations? How can we consolidate services and drive economies of scale in our system, for instance, for laboratory services? And really just how can we impact our community in new ways and reach our community in new ways? And that's the future of healthcare, at least built around this kind of technology. So it really has led to some larger scale thinking about what we can do with this kind of technology. And it's also led us to think about different kinds of automated mobility technologies like these machines. These are what you might call eVTOLs or electric vertical takeoff and landing vehicles. Several of these in the regulatory pipeline now. You could think of them colloquially as, human-sized drones, although at first they will likely have operators or pilots on board. But the point is they're efficient, quiet, electric vertical takeoff and landing vehicles with increased cargo capacity. So as we think about using drones in healthcare, we also think, what are additional steps we can take? Are there systems we can use around automated ground vehicles to enhance healthcare services? And we obviously think that's all possible. It's likely that, or we believe it's likely that healthcare will be an early mover for these eVTOL, these larger vehicles as well, because we have existing infrastructure for aviation, as most people just know intuitively around helicopters. There's obviously public benefit, and we believe that would translate into more public acceptance or accelerated public acceptance, or what you might call social license. Certainly lower environmental impact at helicopters, especially from the standpoint of noise. These things are probably going to be about as loud as a tractor trailer truck at 50 or 100 yards, which sounds loud, but compared to a helicopter is certainly not. And they would fill a large and growing transportation need, as an example. It's an example of another way we can rethink the way we use technologies in healthcare, in this case, aviation assets. But so this is just meant to point to, we have certain mission profiles we think through in healthcare for aviation assets now, like helicopters, but these technologies will completely redefine how these technologies are used and will function more like elevators than they do like aircraft. But just to back up a little bit, because our thinking on this technology, like I mentioned, has really changed and evolved. The nature of this technology, beginning with drones, really does help us rethink those traditional roles. So we've thought of drones, for instance, more like we consider them more of a facility function than a transportation function. And if you know what a pneumatic tube system is, they're ubiquitous inside healthcare systems like ours, basically tubes inside the walls and ceilings of all the buildings you're in. And like the tellers at banks back in the day, you have capsules and you ship small parcels and packages around your healthcare system to every nursing unit through these integrated systems. Basically, the drone system works just like a pneumatic tube system, except for it's very dynamic and we can change where we use it and when we use it. At scale, that can become very powerful. And like I mentioned before, if you thought about drones as tube systems, then the eVTOLs and larger vehicles and maybe even automated ground vehicles, think of them more like elevators and less like vehicles. So we really need to think critically about it. It's about how we're going to use these technologies, and it brings up questions about what these technologies are going to, how they're going to evolve in markets, how they're going to evolve in common use. One way to think about this, or one way to critically examine that, is to think through the concept of disruptive innovation, and that I'm a person who works in innovation day to day. The word disruptive gets thrown around and cannibalized a lot, but it actually means something very specific. We're talking about technologies that often start what you might call down market. They are basically not as good as some of the technologies they appear to be competing with, and so incumbent companies and technologists ignore them because they are addressing parts of a market or a use that is unattractive to those businesses, as an example, or those systems. They then tend to improve over time, and they tend to democratize previously inaccessible forms of technology, and then they tend to create entirely new kinds of markets, unanticipated markets. They start often as cheaper, simpler, and more accessible, but often, again, less capable, just like a drone. If you're comparing a drone to, for instance, a courier system. But you expect that technology performance to improve over time and eventually overtake often the performance of the technologies it is disrupting. An easy way to think about this, we hear this so often in the media, even, that we hear companies like Uber and Netflix being described as disruptive. And then, of course, companies like Apple and the iPhone. Of the three here, and this was designed to be done in person, but of the three here, I would normally say by a show of hands, which of the three, Uber, Netflix, or Apple via the iPhone, is a truly disruptive, based on this definition, company or technology? And the answer is really just the iPhone. Uber and Netflix were very disruptive to the businesses they cannibalized, but it doesn't mean they were disruptive technologies, and it doesn't mean they're going to create entirely new markets or ways of living. Drones and automated mobility technologies may in fact be disruptive, the way the iPhone was. I mean, famously, Steve Jobs underestimated the iPhone's impact. He believed it would just be a really cool combination of a phone, an iPod, and the first device to truly give you the internet in your pocket. He did not. Nobody at the time anticipated widespread proliferation of apps, which redefined businesses. And as another example, they've even disrupted photography because they democratized photography in ways nobody anticipated. So that's the kind of technology we're talking about here. Bringing that back to drones, it really is a moment looking at these kinds of technologies where this could be the case. They democratize an aviation and aerospace transportation technology. They're not as capable right now as the alternatives. They're certainly a lot cheaper, and they certainly serve markets that are not unattractive in some ways to incumbents. But we expect that to change over time. So if you view these technologies through this lens, it really does make it easier to reconsider its uses and impacts and the implications of the technology more broadly. So to situate that around sort of how it's evolving now, you've got the simple drone, and this is a picture of our drone with UPS's box on it. And this is a Matternet drone. This picture was taken at WakeMed during one of the demos. You get a couple of axes here. If you're UPS, you're looking at this technology and you're situating it on the spectrum of your current tools that you have at your disposal to fulfill your mission and to serve your customers, and that's appropriate. Somewhere between a truck and a 747, right? So is the simplest way to think of it from their standpoint. I mean, in some ways, it's an aerospace technology. It's clearly being regulated like an aerospace technology or an aviation technology. These are connected and automated, and frankly, as a former airline pilot, I can tell you that that's true of commercial aircraft already. But on the other hand, these devices and this technology functions more like a ground technology. It requires a deep ground side integration. It really does create interactions on the street level down into communities in ways that obviously aircraft never will and never have. So it really does raise questions about how this technology will work and function. And then, sorry, it's having trouble advancing. There it goes. So you might then think about this on the other axis. You might, if the previous axis was like the incumbent axis, this axis would be a disruptor axis. And that is when you start thinking about this technology from the viewpoint of an urban planner or an architect or a civil engineer. And this is where it gets really interesting, because these technologies can function like bridges. They physically connect locations. They hopefully will be open to public use eventually. And like bridges, we believe that they will need to be governed by civic authorities. This is a technology that exists and operates in the public domain. It has to be developed ethically, and it has to be governed from the ground up. That's an important concept, and that differentiates this technology from other transportation technologies in some ways, or other mobility technologies. Like a building, it can support livability, it can support commerce, create a commons concept, connecting distant locations very seamlessly. And the easiest way to think about this is it leverages the third dimension. I mean, when elevators were invented, it completely reshaped the way cities are built and function. No reason to think that this kind of technology won't create similar changes in the way we build our environment and the way we interact with our environment. So you really are left with this strange sort of category-breaking technology or suite of technologies, and that's been one of the difficulties in figuring out exactly how we're going to manage and grow this technology, because it doesn't quite fit. So the FAA can regulate it as an aircraft, but that only covers it down to a few meters off the ground. What happens on the ground? How do you integrate its functions into businesses and communities? Because of all that, these technologies really do act like an extension of infrastructure, and that's an important concept. So a useful construct to tie this all together, and a way to think about it, as we've come to realize, is referring to it as a cyber physical infrastructure element. And many of you I'm sure many of you that are listening to this are engineers and understand what cyber physical systems are. Clearly, an emerging cyber physical infrastructure would be called for and would need to be developed as an ecosystem to support this technology's best use. What we're talking about are things like environmental data aggregation, data sensors on the cyber side, figuring out ways to codify governance and regulatory pathways and frameworks across digital technologies, because this technology will be very distributed. Thinking about cybersecurity and privacy will be critical for this technology. They're also physical. They're actually vehicles. They will need physical objects in the environment feeding them data. They will need places to land, vertiports and vertistops, recharging stations, and electrification infrastructure will be important. And they will require structural integrations. I can tell you that we're looking at that at WakeMed right now. We're looking at, in the future, how will we integrate packages from these vehicles directly inside of our buildings, for instance, without having to send a human outside. The implications for this, for the physical and built environment, are substantial. So, thinking about these things through that framework, you have to build out every part of this ecosystem, the cyber side, the physical side, and knitting it all together as an infrastructure. The image on your screen is an example of the first. This is NASA's concept. NASA, among other things, is in charge of basically creating the agenda and the ecosystem of digital technologies that will integrate these flying vehicles into the national airspace system, or at least segregate them safely. That is a lot harder than it sounds when you're dealing with multiple industry players, multiple new entrants, and multiple types of technologies before the standards have been developed. So basically, they're a standard setting organization in this case. This is their concept, and please don't look at this too much or you'll go cross-eyed, but just to give you an idea of how complicated it is, this is their basic concept of communicating how that might work in looping this technology into the airspace system. You've got to think about building an environment that will support this technology. That will come at substantial expense, but also have substantial benefit. Some of you may know about Uber Elevate. Uber Elevate is a concept around urban air mobility, as they call it, where they imagine adding a third dimension to urban transit systems as cities become more congested. And to do that, they propose to have thousands of eVTOLs swarming essentially in and out of large structures like the one you see on your screen, and then much smaller outstations and landing sites out in communities to alleviate congestion and change the way we travel in cities. Certainly that is a moonshot of a concept. Certainly it's something I think a lot of people in the industry are interested in pursuing, but we've got a long way to go, and it would require a substantial investment. But what you're really thinking through here is this entire knit together ecosystem and how a city or a community or even rural areas will react, how it will all fit together in a coherent transportation sort of strategy that will actually be usable, economical, and safe. So you're really just thinking, excuse me, it's thinking about this from the standpoint of, say, smart city development or powering these cyber physical systems to sort of knit this ecosystem together. So bringing it back to healthcare, what does this have to do with healthcare? Well, it's a fair question. As we've gotten more experience with this technology, and as we've experimented with it, and as we've thought through how we might use it, it's clear to us that the potential is significant for us to more deeply integrate into our communities. So we're basically a microcosm of an integrated infrastructure technology. Healthcare systems like ours are critical to the health and well-being of a community. We're deeply integrated into our communities physically and also through the health of the community. We're really a lot of different businesses put together. We're not just a healthcare company. Healthcare companies do just thousands of different things under one umbrella. Our final product is theoretically to create human health and healthy communities. We reach every level and every aspect of society and enterprise because of that. And a lot of what we do is what you might call socio-technical. It goes well beyond technology and reaches across to the human side and the human elements. So successful communities and cities, we believe, and even economies do require robust healthcare systems and services, and we are part of that infrastructure. And we are working towards a future state where we can create more advanced healthcare systems to benefit our communities. We're thinking beyond connected cities and connected communities, beyond smart cities and smart communities to responsive or adaptive healthcare systems and communities. And that's where this technology can start to move the needle for healthcare, and basically as a microcosm for other businesses and other systems. So we really do, as we think through how the technology will mature, and we think through how companies like ours, like WakeMed, will interact with the technology, we see ourselves in the midst of an evolving ecosystem with multiple, basically a suite of technologies informing the way we design and lay out our system. And we take it as our role to expand that and to continue to participate in the ecosystem as it develops to the benefit of our communities and for human health. So I'll stop there. I won't read these takeaways out loud, and I'll save the rest for any questions that anybody has at the end.
That was excellent. Thank you, Dr. Ginn. Great to take a deeper dive into the topic, and Josh Dodson with Cisco is going to be able to carry us through some more elements of connected transportation. Before Josh gets started, I just want to draw everyone's attention to the questions tab in your control panel. Please submit any questions you have for Dr. Ginn and then for Josh as well as he's presenting. Please go ahead and send us those as you have them, as well as who they are directed towards, and we'll be compiling those for a Q&A session immediately after Josh's presentation. So at this time, I am going to transfer it over to you, Josh. Stuart, you can deactivate, and we should be good to go. One moment. Josh, you should be able to share your screen now, and we can see you. So whenever you're ready.
Did you say you can already see my screen?
Not yet, but I can see your webcam.
Okay. There it is.
Great.
Perfect. Well, Natalie, thank you very much. And just wanted to start off by saying thank you to RTA, RTCC, NCDOT for this event. I usually spend about 50% of my time traveling and attending conferences and presenting, and been locked up for a while now. So this is a nice refresher. Even though it's virtual. So I appreciate the time, and thank you for allowing myself and Cisco to participate. Also, wanted to thank Dr. Ginn. I'll talk about a couple of things as I go through my presentation, but he hit on a couple of key areas that I also want to kind of highlight and bring it full circle. But during this quick agenda, I want to talk about, I'm going to start out with where we are today. Dr. Ginn talked about, a three-dimensional transportation environment. I'm going to bring it back down a little bit closer to earth, and we'll talk about two-dimensional and what we're doing along roadways and where we're seeing the market kind of shift and where we're headed for the future. And then I'm going to wrap up with a few emerging use cases that we're seeing. So when we started out on this journey, as a hardware vendor, right, 30, 40 years ago, connecting devices, and as this IP, internet-based system has kind of evolved, we started in the data center, the closets with the switches and the routers, our office space, right, connecting printers. Our desktops, those kind of things, and we've started to move right into, okay, well, let's start connecting up warehouses, and maybe we can automate some of our distribution centers to make things a little quicker and faster, and then also expanding into what we call the non-carpeted space. So we think about like parking lots, so we can start having enabling CCTV, have real-time insight into what's going on to some of these remote areas that the network is now connected. And then as we go a little bit further, you can see that now we've started looking at, okay, well, how can we start bringing some of these legacy or closed systems on to IP, and then we can start taking advantage of what some of our IP enabled tools will help us. So we're talking about, putting hardware into street traffic cabinets, NEMA enclosures. For smart city use cases, maybe a wayfinding application, we can have kiosks, in city centers. Being able to put, mobile routers to connect our fleet vehicles, or, create traffic signal prioritization for first responders, or have a vehicle area network. So these are the kind of areas where we are already moving into. And then kind of in tandem, another area that we've really been over the probably past 10 to 15 years is this field area network. So we think about like utilities and industrial control systems. These are systems that have been in place for, sometimes 30, 40 years. They're very closed because, if they were open and we had ransomware, malware attacks, then, there could be, loss of life and other catastrophic events. So let's take a look at kind of where we see the typical journey for these customers. Phase 1, 1.0 is we got to connect the things to the network, right? So no matter how we're making that connection, we have to have a real and secure connection. But once we have them connected, then we can start looking at, okay, let's do some remote monitoring and controls. Where are our vehicles today in real time? What are we seeing? Are they speeding? Are they taking hard turns? These are the things that we can start really focusing in on. And once we have the connection and once we are monitoring, then we can start really looking at what are those data-driven business outcomes. And that's ultimately where we see, automation take a new shape. Cross-domain correlation, a great example of that, and I'll go back to the parking lot, was, maybe at 3 o'clock in the morning, we may not have anyone in the parking lot, so we can lower our LED lights that are controlled by the network. But then also we can have some correlation with, maybe how many people are utilizing parking decks at hospitals and other things. So we can start really looking at, instead of just a standard closed platform, we can see some of this cross, correlation happening. And then ultimately moving into an area where we would have what we call a digital twin. And that's where it gets really interesting, because then we can have this digital twin of exactly what our hospital may look like. And then we can start utilizing it maybe as a lab environment where we can start setting off, events that would happen. And then we can see, what kind of alerts are going to be created there, or, down the line, what are maybe some unanticipated consequences that we didn't see. So when we move into a true production state, then we already have, taken a lot of that initial, cause and effect, and maybe not really understanding what some of the additional consequences may be for some of our actions. But at the end of the day, and Dr. Ginn hit on this, is, security and that connectivity is the foundation of these networks, right? So as we start to use technology to change the way that we're kind of working, again, when we start talking, especially in roadways and industrial control systems, if someone were able to find a vulnerability and exploit that vulnerability, then, there's catastrophic events that can happen, and ultimately loss of life, and that's what we're really trying to avoid. So quickly, I want to talk a little bit about where we see this journey from kind of where we started with just our traditional network, right, where we were connecting devices like I was talking about, and where I see us really heading. I already talked a little bit about the programmability, right? So the digital, having the infrastructure in place, connecting those things, looking at the policy-based automations, what kind of controls we can have. But then where I really feel like we are today is being able to look at the analytics and seeing some of that assurance, right? So really understanding what type of sensors, sensors can be anything. We can, we can have video cameras as a sensor. We can have a really dumb, like Wi-Fi based or LoRaWAN based or cellular, backhaul device that may only understand that it's doing one or two actions, so we can extract that data, but really being able to see, okay, historically, creating that baseline and looking at what's happening in real time so we can start understanding a little bit deeper. But then in the future, where I see us really moving, and we're going to really extract a lot of value from, connecting these things to, or these devices to our network, is looking at the machine learning, really having that predictive, the predictive analytics, right? When we have a baseline, then we can start seeing, okay, our elevators typically break down, at a certain point, so we can start doing predictive maintenance and other things, so our assets don't have downtime, but when they do, they're scheduled downtime, and that way we can have more of a holistic approach, and we make sure that the network's going to be up and running as we're applying some of these mission critical infrastructure devices to that network. But the ultimate goal, again, is that intent-based networking, where we have, our network really acting as a proactive learner, and it's adapting based on policy changes that it's already seeing and predicting, and then constantly changing and fine-tuning maybe those dials or our security protocols to ensure that we're using the network to act as a true sensor and really a tool that can run on its own. And so I want to give a kind of a real world application here within the roadway. And so just, think about this as, we've got a NEMA enclosure, the big silver box we see at the intersection or along, 540 as we're cruising down at, 70 miles an hour, because, we're all obeying the speed limit. But here along and I'll use my mouse, but we see kind of in these blue areas, right? These are the devices that we today already have on the roadway. So we've got loop sensors, right, for maybe signal phasing and timing, radar to understand how fast traffic is flowing. We may have our CCTV cameras feeding back to a video server. Our digital message signs, the dynamic signs that we can change, those are going back to the DMS servers in our data center. Then again, we have our radar and loop sensors in a different area of the roadway. And then maybe we also have some weather sensors. So as you can see, each of these devices, they feed back to their traditional server. That's all well and fine, right? They function properly. We know that for the most part, pending an event, they're going to be up and running. But what it does is it creates these siloed systems where we don't have, and as I referenced earlier, some of that cross-domain pollination. So let's look at what if we were able to take moving some of that, the compute, the application compute that's happening in the data center. What if we're able to move that into, in a rugged environment and put that along the roadside? US DOT requires that any action that's going to be taken that's automated has to happen in half of a second, right? And so being able to move to the roadway changes the way that we can kind of interact with these devices, because instead of having to take that data from that roadway sensor, right? So from our radar or our volume sensor and going all the way back to maybe a cloud application or to the application housed in our data center, wherever that may be, we can start taking what we call some microservices or having some lightweight applications running in the cabinet. So we can start seeing, okay, in real time, we still have these same sensors, right? So radar for volume and speed. We start seeing, our cameras are seeing what's happening in real time. This is a DSRC radio. So this is something new, right, to the mix, where we can start picking up what they call basic safety messages off of vehicles that are already equipped today. And then we can start cross-pollinating some of these. So let's say that, we're flowing right from south to north and speeds are, around 77 miles an hour. Everybody's happy cruising along, but up ahead, we see that traffic is stopping for some reason. So when we're using these vehicles as a sensor, we can start picking up some other things that are happening there through some of this basic safety application information. And I'll share with you a screenshot of what that would traditionally look like. But using the software, we can start acquiring the important data sets. We can filter out what's important and what's not really important for that specific application. And then we can run local logic. So, in this example, using the vehicle as a sensor, if we see that traffic is slowing through this radio here on this lightweight application, then we can say, okay, let's go ahead and reduce the dynamic message board, right? So instead of speed limits being 77, let's cut those down to 55 or 45 so we can start really understanding what the event is that's happening up ahead. And then we can also, through a basic safety message in the future, we'll actually be able to push a, hey, slow down alert from the corridor or the intersection via the radio, and push that, and it may display, in your Tesla today that, hey, you need to slow down. There's an event happening, and maybe that's a hard braking event, airbag deployments. These are the types of messages that we can pick up. So, and I won't spend too much time here, but I wanted to show you exactly what a basic safety message looks like in the data format and why that's important. There's a lot of things that we're picking up in here about location, lat long, right, speed, heading, acceleration events. What are some things that I may not really care about that I can drop those data sets right there at the edge? I don't really need to know 10 times per second what the air pressure is in the right front tire of a vehicle. So looking at picking up what are the important data sets in the events, using Edge really kind of changes dynamically not only the business outcome, right, where we're acting quicker to solve events, but then also on a manageability and reactionary and a basic infrastructure just from the servers that it takes to run some of these applications. And I won't go through this through every one of these boxes, but I do want to call out a couple of points. You know, without edge processing, we're talking about 19 terabytes per day in use cases and that's a lot of storage. You know, we start talking about location and GPS for context. And if you look down here at the bottom, I just want to highlight the yellow boxes, because with no edge processing, again, we're talking about 19 to 20 terabytes per day. And we start looking at, and that's per car, and we start looking at, okay, or per corridor, I should say. And, you know, we start talking about 7 to 8 petabytes per year per mile. You know, for budgetary purposes, that's extremely expensive. So just by allowing some edge services, we can really cut that down by almost 900%. And that makes it easier on staff and also on these business critical applications. So quickly, I wanted to talk about some emerging use cases, and use cases are different for every customer. But the pedestrian detection use case is something that has been really prevalent. I had a customer that I was working with, and they actually were looking at a different priority for the first use case of rolling this out. And unfortunately, they had a wrong way driver and a pedestrian death. And so it started changing from, okay, let's look at the, you know, creating relevancy in the business and start looking at maybe safety and security, right? And that's huge in public sector. And so just really quickly, as one example, you know, we can have a sensor at an intersection, and whether that's going to be by video or maybe a Lidar sensor. And for those of you that are not familiar with Lidar, it's a laser that spins extremely fast and creates basically a 3D model for what's happening in that area. And so we can see that pedestrians are in the crosswalk, and based on their telemetry, they may not make the other side of the crosswalk before the signal phase changes. So then we can start moving that into our compute node like I was talking about, and then we can push that out via DSRC, and we can create warnings, right? So that pedestrians know that they need to move quicker. But then we can also adjust and have adaptive signal phasing and timing. So there locally, we can integrate directly with the traffic controller, and then we can, you know, we could in the future really change dynamically, maybe cycle by cycle, how that signal phases. But then we can also at the same time create an action alert and send that message back to maybe like a traffic management center so that they're aware of the events that are happening. So the next use case would be a vehicle as a sensor. And again, this would be just using the integration, so the radio that's built into cars today, and then, you know, whether it's DSRC today or, you know, cellular V2X, whether it's, you know, 5G in the future, I don't think that really matters because, you know, again, it's just a radio. So being able to acquire the data and, you know, aggregate that data for where it needs to go, pick out the important pieces, but then drop everything else is really the key takeaway. So being able to use that vehicle as a sensor, so acquire it by the radio, take action on it at the roadway, send that back to the traffic management center or a cloud application, you know, maybe for data pooling and for other things. But again, being able to have that millisecond, you know, action at the roadway is really the key part. The environmental detection one is pretty interesting. And this is one that we have a few different type of environmental sensors. We have fog sensor deployments for visibility. You know, we've got use cases where we're doing, maybe rain converting to ice, in the north. But again, being able to apply logic, so use that vehicle, use that sensor, change, maybe it's speed limits, right, with fog. So, if visibility is 10 miles, then, our speeds are going to be what they are. But then as, visibility starts to drop, dynamically, in real time at the traffic cabinet, we can then reduce speed limits, and we can also, again, send that information back to TMCs. Again, I already touched on this one a little bit, but wrong way driver application. We found that the average time to remediation from when a wrong way driver incident begins until we safely can stop that driver is typically 8 minutes. So you think about, Granny driving down the road at 70 miles an hour in the wrong direction, or, a drunk driver driving down the wrong way at night. Obviously those events and consequences can be devastating. So being able to, shave minutes or even seconds off of that detection, and, again, dynamically in the traffic cabinet, change, maybe our gantry signs, right, and say, hey, stop, pull over, wrong way driver detected ahead, and then dispatch first responders, and again, creating the alerts with Traffic Management Center. These are the types of applications that we can support today. And again, we're just going to see more and more innovation on top of that. So, Natalie, I will stop there. And if you want to go ahead and take control, then we'll go ahead and move into the Q&A portion.
I will do it. Thank you. That was excellent. At this time, I am going to turn it over to Joe Milazzo, who is going to moderate our Q&A. And Joe, I will keep my screen active for the background, and let me know if you need anything else.
That is perfect. No, let's pause for just a moment, everybody, and give thanks to our two speakers, both Joshua Dodson and also Dr. Stewart. Again, let's pause for just a moment. Do that. So everybody do that. And we're going to go straight into the questions. And so we've received one in the chat. I've received them from some other methods as well. So folks are communicating with me that way and with text. So we're going to go and have at it. And so the first one will go to Stewart, and so we'll go to Dr. Ginn. So we'll go activate his camera, and then we will and go from that standpoint. And this is a question from one of our partners with NCDOT. And the question was, have air rights been secured over public roadways, or do they need to be, specifically in agreements to operate and for conditions for operating over traffic moving on the ground? So in this case, for the drones, on top of vehicles, pedestrians, bicycles, other normal users of the roadway and street network. Anything that you could offer on that?
Yeah, that's a great question. And maybe that's the $1 million question that we're waiting to answer. So the short answer is yes, for the route we have now. The strategy through the FAA right now is for the system we are building is route by route. So we look at the two facilities we want to connect, and then collaboratively with actually the North Carolina DOT Aviation Group and local stakeholders and the technologists and the operator, in this case UPS, think about what route is appropriate based on things like population density and based on exactly like you mentioned. And I think one of the large, and I don't have direct insight into this in terms of day-to-day discussions, but I know that the question about, for instance, can we fly these vehicles over I-440 between our Garner Healthplex facility, which is our next one to be linked, and our main facility to the north. And that's been a significant sort of source of consternation. On the one hand, you have to weigh the risk of a 55-pound vehicle, although it does have a parachute recovery system on board, but you have to weigh the potential effect of that dropping onto a highway with fast-moving vehicles against the probability of that occurring. And of course, you're doing that in a world where deer jump out in front of the traffic on those roads all the time.
Right.
So it's all about thinking through what are the relative risks and costs of this technology. For our first route, that was our first, in fact, the first waiver we got as an operation to operate our first route was a waiver for flights over people. So the FAA takes this currently on a case-by-case basis. In the future, the goal is to have a regulatory framework in place that will allow that to be codified in the set of regulations and allow other people to use the technology in an expanded way.
That makes sense. And just a quick follow-up on that. Anything that you've seen from other markets? Obviously, you're the first in the country, but are you familiar with any other conversations happening in other states that are dealing with that issue as of yet?
Oh yes, concurrent with our operation, there was Google and is in the IPP in Virginia, and they're doing deliveries of, I think, small packages to patients, not to patients, just to consumers' homes in rural areas. Our partners, UPS, now have an enterprise called UPS Flight Forward, which is the world's first drone airline. Basically, they have what's called a Part 135 operating certificate to operate drones, and they are actively setting up operations just like ours in San Diego, at UC San Diego, and I believe at the University of Utah, and probably many others in the near future. So those things are happening quickly.
Well, we'll all be learning together and through the governance issues that have been mentioned earlier in this presentation. Yes. So that sounds good. Let's go, and we're going to switch over to Josh for just a moment. Here's the question. And it speaks to the very kind of the core of what you were speaking today, Josh, about edge intelligence and just moving the sensors and moving the calculations right there at the interface and so on. Are the primary benefits that you've seen on that and what you expect to see going forward, are they more on the operations side? Are they more in safety? Is it more maintenance? Is it storage? Is it kind of all the above? But as we think through that and we're just kind of getting our feet wet with edge intelligence, where do you see the primary benefits for edge intelligence, and do you think it'll change over time?
So the answer is D, all the above.
Right.
Just like with any standardized test. But public safety, right, is number one. We're trying to change the way that we're working with some of these systems, right? And so sensors, I like to say are our fingerprints, right? I mean, they're our eyes and our ears, they're our senses, out in the wild. So while we are creating great business outcomes, right? Because we're reducing storage, where turn times are being reduced, right? We're getting on scene faster, those kind of things. Again, it all ties back to, in the public sector, safety and security and citizen services. In the commercial space, it's a little different. It's more around like ROI. But again, in public sector, it's all about the citizen experience.
That makes sense to me. Here's a follow-up from you. This is a question that's arisen. You mentioned some of the use cases today. You talked about the pedestrian detection. You talked about wrong way driving, different signal phasing, and so on. One of the things that all of us experience as members of the business community or just anybody traveling around is our interaction with our intersection systems, the freeways, the intersections. Does edge intelligence, to these sort of sensors, do they offer some promise in terms of reducing maintenance costs for our cities, our towns, for DOT? Because I know one of the challenges we all experience is when that signal is showing green for no one, when it's because a sensor has failed, and still have to show it from a safety standpoint, to your point. Is there elements of this that look like in the future, whether it's on the edge intelligence side or different types of sensors, could start reducing some of those maintenance cost, operations, downtimes for our communities? What do you think about that?
Yeah, you hit the nail on the head. So there's a couple of different ways that the maintenance is going to be greatly reduced. One, street lights, a great example, right? Somebody comes through, hits a pole, lights are flashing. So today, typically it takes someone to call and say, hey, the light's out. With edge intelligence or any kind of edge software, what would happen is we could know the moment that light went down because it's no longer connected to the network. So not only do we create an alert, but then we can also create an automated truck roll. So instead of someone calling in, someone opening a ticket, and then them calling a truck, to roll, we can go ahead and create that through the ServiceNow, Salesforce, depending on who the customer uses, and we can respond quicker to that incident. And then also, let's say that we're doing security patches. Instead of having to have someone go and touch each one of these devices to upgrade the devices, we can actually do that through policy-driven software and push that from a controller-based system.
Okay, that sounds very, very attractive, I think, to a lot of the folks on this webinar and others as well. I'm going to bring Josh in, but also keep you in for the next question that's arisen. And this is a question about equity and vulnerable communities. This is an issue in America, certainly in our market, that has come up increasingly. So Dr. Ginn will come on as well with his video. In terms of we thinking about equity, do either of you see these technologies, whether it's vertical takeoff and landing, whether it's or the disruptive drones, edge intelligence, sensors, the ability to provide new information, better information, more disruptive ways of moving things within buildings or between sites? Do you think any of that would start finding ways by reducing, essentially bending the cost curve down, creating more of an improvement for all the vulnerable members of our communities, or even in some conditions? I'll just pause for a second. And that's a different one than we might have expected, but I think it's an interesting question.
So I can go first. I certainly, as somebody who works day to day in delivering healthcare, and at Wake Med, we are the county healthcare system. We are the safety net system. We take care of everybody in Wake County, regardless of ability to pay. Yes, so there, as you allude to, Joe, with any new layer of technology, we can include all of these subsystems we're talking about. There's the opportunity for creating worsening gaps instead of improving those gaps. I can tell you that in healthcare, while that risk exists, if we use the drone as an example, we think there are direct applications where we can literally improve access to healthcare services into our community in a very, very efficient and low-cost way using this technology. In other words, we can improve the services that we can offer in more locations if we can scale this technology, because getting the lab tests or medications or small devices or whatever we might need to those locations becomes much more seamless, and the transaction cost of accomplishing that decreases significantly. So that's our hope, is that we can decrease barriers to access to healthcare with this kind of technology.
Okay, and so I'm going to follow up with you in a second about whether that relates to the value-based care conversations that are going on. But let me hear from Josh first. Any other reaction, either what Stuart said or just the overall question on equity?
Again, being able through automation to reduce response times, and the public safety aspect, I don't think that's necessarily any kind of a disruptor, right? But as far as the value from, I would say, moving to an IP-based system, right, or bringing what we have in IP and applying it to some of these the technologies, the historical technologies that haven't been connected, I think the benefits outweigh any kind of potential costs. Specifically around cybersecurity, for instance, we're seeing nation-state actors that are focusing more on these industrial control systems because of the vulnerabilities in IP security. And so being able to push that security policy all the way to the edge device that's the closest to the sensor, I think that changes the game for the way that we look. And again, weighing the cost versus the benefits, I think it's a no-brainer.
That's good. That's good information. And again, I appreciate your focusing on the security element of that. I think that is a good takeaway for all of us today. Next couple are going to be for Dr. Ginn, just for now he has that. So one question will be related to the prior one, which is about value-based care and that concept. Is there any element of this sort of disruptive technology that would help that process in any way in terms of getting things to the communities faster and more inexpensively? And then a related question may be just the overall, what has been the most surprising positive impact of the program in general?
Okay, so to value-based care, another $1 million question, right? So we always think about that as we consider new technologies and new systems in our healthcare system. We obviously see our healthcare system shifting globally. I'm not talking about WakeMed, I'm talking about everybody towards a value-based environment, and we have a long way to go. When we think about this particular technology factoring in, it's all about. I really do think it comes down to access in terms of how do we. Maybe I can put it this way: when we think about this technology, we don't think about, okay, what small package can we move from point A to point B? It's really, how can we redesign our healthcare system with this technology in the back of our minds? What can we do to reach our community faster and quicker and improve services? Now, you have to factor in the cost of all that, and certainly there will be, at a certain scale, substantial cost benefits to this. To using this technology. And I will use as an example telemedicine services. So this technology could power up telemedicine services, which could be very, very high value in new and creative ways. There's a lot you can do, as we're learning, by the way, very rapidly right now. There's a lot you can actually do through a telehealth service, just through a virtual presence. But there are also significant limitations to what you can do in healthcare using that technology, because at the end of the day, you often need supplies, tests, and lots of other things on site, and you need to connect the expertise with the patient and the need and all that gear. This is technology that could be a part of a suite of technologies that powers telehealth systems, and we definitely believe that telehealth systems, especially powered up like that, could really move the needle on in terms of cost and access.
That's right. And of course, cost and access are twins in terms of how healthcare is going to move long term. Any other surprising things that you've seen in terms of this impact of the program in general? Anything else that is just like, didn't anticipate this one coming?
Yeah, so maybe the most surprising thing to me is the person who kicked this ball down the hill was the impact. We kind of anticipated, and with our partners, North Carolina DOT, we were prepared for this, but we anticipated that as we started operating these vehicles on and around our campus, we might get significant feedback, both positive and negative, but we anticipated significant feedback from patients and visitors and even staff. What's been incredible has been how invisible and inconspicuous it has been. It has really folded into our operation in an incredibly robust and fluid way. And obviously we've got a lot of work to do to scale it, but that's been quite surprising.
That's very cool. I'm going to go bring Josh back in here for this next one. And it goes back to one of the use cases that you mentioned, Josh, that I found very interesting, both in the preview and again today. You talked about the pedestrian detection use case, how it actually came actually from a different method, entirely different initial focus, taking it more just at the basic level. We've got pedestrian buttons all over the place. Would the pedestrian detection method that you're talking about, do you believe that either now or in the future would enable us to essentially eliminate the pedestrian buttons we have at intersections or not? Or what are your thoughts on that?
Yeah, absolutely. And it's interesting because each customer, they have a different level of comfort with moving, to an AI type of enabled intersection, right? So we have certain customers that, they may see an alert, and instead of creating a policy to go ahead and like change a sign, right? They want an alert to be sent back to like a traffic management operator, and they have the alert, then they have the option to like push a button. So what I tell all of our customers is, you don't want to go from, crawling to running marathons immediately, right? It's a journey. And so, we typically create a staged approach. So we can create, a policy, an alert where, it pops up on their operator screen and they press a button, or we can fully automate the system. As we move to like a level 5, stage autonomy with cars that we really do get in and can take a nap, yeah, all of this will be automated. But that's years and years down the road.
Okay, that's good. But just for what it's worth, as we think about things, I hate close to home, but right now with the coronavirus that's going on, and we'll go bring Dr. Ginn back in for the next thing here. Any technology that can make it so people don't have to touch buttons out in the field would probably be welcome. So in terms of pushing that button at the pedestrian before you cross the street, if that can become automated, and that's one less touch surface that people have to do. So that's exciting. Let's go ahead and bring Dr. Ginn back in. We'll leave Josh on as well. So the general question would be coronavirus, or even more broadly than that, just infectious disease, just in general, things that we're going to, pandemics long-term as well as right now. Edge computing, do you see any ways where this is going to help us in terms of providing more information sooner? And Dr. Ginn, I'm going to say you don't even have to limit your thinking here just to the drones, which I know you spent a lot of your presentation, very well done on that. But things as we think about new testing, new information, contact tracing, all the sorts of things where more information, more speed is going to help communities be successful in terms of reopening or staying open. So that's a little bit of a challenging one, but I'll just open that up to you all as we think about a very hot topic right now.
Okay, so yeah, that's a big question, and where I've been spending my life, at least I'm sure like all of us for the last month, especially as somebody who looks at innovation inside my healthcare system. The groundswell changes that may occur in healthcare systems going forward, while they won't happen overnight, I do think, just broadly speaking, that this event will sort of wake us up to creating a more adaptable and responsive healthcare system. And I think that's kind of thematically the way to think about it. That includes things like widespread testing and a testing regime and the strategy around it. How do we make it safe to open economies again? For that to happen, you've got to be able to share, secure, collate, and analyze that level of data. That's something we don't know how to do right now. And we know how to do it, but something we don't do very well in healthcare. We silo our data like everybody else does. A lot of it's proprietary between different information systems, and that will have to change. That translates right down to the drone, right directly to drone type systems and automated mobility systems. In the sense that, again, back to that concept of, sort of what could we have done? Imagine if we had a fully developed drone network and the ability and the social license to adapt it to this crisis. We could have probably accelerated and made an impact on the testing situation in the short term, although that's very complicated and has to do with the supply chain and a million other things. So you really do need sort of a massively scaled system to make an impact, but still it all holds true. And I also think the final thing I'll say is I think it's become an interesting discussion around social distancing. In the world of drones and maybe all automation technologies, the conversation very rapidly went from one where we were concerned about those issues and decoupling the technology from the human side for a lot of really good reasons, to now seeing that there are situations where it can be an asset. And so I think that's an important concept as well.
That's good. Josh, any thoughts on the overall impact of the pandemic and technology here?
Yeah, so it's interesting, we're hearing about the partnership that's happening right now between Apple and Google, and they're trying to create this application. So, once people are tested, then maybe it's it's tied to your phone. But from a public safety standpoint, there's a lot of red tape around being able to anonymize who folks are. Right, we can't share because of HIPAA and other things, medical information, and that's something we can help with, kind of with that edge software, is being able to anonymize. Right, so maybe there is a COVID application in the future. What stick in whatever code word you'd want, but and then you can kind of see where hotspots are, or it's all about. You got to have a sensor, you got to have something to be able to collect the data or display that data, and then, right, we can contextualize and take action on it. So I think that's the biggest takeaway.
That makes sense. So I got a couple. We're going to do the rapid fire portion. So we're going to have 30-second answers for the final thing, because some questions have come in real quick. One would be, let me see if I get this right as I'm doing the scroll through. Next, if you're going to pick just one more application for drone technology beyond what we've already talked about right now, what would it be? This is from one of our county commissioners, Sig Hutchinson. So just a quick one.
So one addition. So I'm sorry, it was one additional healthcare related.
Could be health. Yeah.
Yeah. So I mean, very simply, bigger cargoes, farther distances. So the easy way to think about that, and the easiest concept would be organ delivery. So thinking about linking healthcare systems, different systems together on maybe a regional level, and maybe even larger, and using these vehicles in a long chain of or a suite of transportation technologies integrated into our healthcare information systems would be an incredibly powerful tool to have in healthcare.
That's a good one. One quick one from one of our fellow panelists, from Dr. Hummer. This is for Josh. Liability involved in sensors and warning instruments. We talked about security, haven't talked much about liability. For an agency's perspective, if a sensor doesn't work 100% of the time, what are your thoughts on that?
So I would flip that around. Sensors and IP-based information is typically way more reliable, right? I mean, it's 99.9% uptime, and we're actually taking the human element that is actually a lot more prone to making mistakes and maybe missing things. But we actually have we try to architect our networks so there's actually redundancy and resilience. So if one sensor does go down, it doesn't collapse a mission critical application. But again, an IP enabled sensor is going to be way more reliable and takes the human element out of it.
That's a good response. Final one here from Dr. Ginn, for Dr. Ginn, this is from Kevin Miller with SAS. Current payload capacity for the drones right now, and has it increased?
Yeah, so the Matternet M2 drone, you can look that one up, Google it, has basically 2 kilograms for basically 4.5 pounds.
Mm-hmm.
Interestingly, that's more than enough than we need. We always run out of volume before we run out of mass, because we're shipping a lot of high value small cargoes. And an analysis we did in our system ahead of all this showed us that, maybe like Amazon used to claim, I'm not sure if things are the same now, the vast majority, something like 75 or 80% of the cargoes that our couriers carry are in that range.
Oh, very cool. So, well, I think we're just about the end of our time here. We'll do some wrap-up remarks, but before we do that, let's thank Dr. Ginn and also Joshua Dodson for fantastic, not just presentations, but also engagement and Q&A here. So let's give them a round of applause for that. Everybody's, you may not be able to hear it, but it's in the background right now. They are, from a socially distant standpoint, they're offering applause for you and for your time. Thank you very much for your time today. And then Natalie's going to show the final screen again, so we're going to talk about some upcoming events here from RTA. Right to the end, there we go. And so those, actually go to the previous one, Natalie, I misspoke, just the previous one for just a moment. Yep. So again, we want to thank our partners at the Research Triangle Clean Tech Cluster and NCDOT for their partnership, not just today, but also yesterday's event. Both of the webinar recordings will be posted by the end of the day tomorrow at the website you see on the screen. And you can also follow along, again, looking at the social media, continue to have those conversations, continue to have those interactions going forward. And we'll go to the next slide as well. Our next RTA event coming up, and we are hoping it's not socially distanced, it will be an in-person event, our RTA 2020 Transportation Breakfast. It's entitled Freeways of the Future. It's on July 17th in the morning at the Umstead Hotel and Spa. You can see the website there, letsgetmoving.org/breakfast for information about it, for details and registration. RTA members, of course, this is included with your membership, and we look forward to seeing you there. And we're going to be very confident that we'll be able to do that in person. Freeways of the Future, and included in that will be a conversation about the FAST study, at least a draft release of those findings that we learned yesterday from Taruna with VHB. So this concludes our webinar. We want to thank everyone for your time today. We want to thank our partners. We want to thank the RTA leadership team for their work and their effort to constantly looking to improve the future of mobility through business leadership. Thank you very much. Have a great day, and let's get moving.